Unit 11 exam review, covering Section 1, arc length, and Section 2, area of a sector. Very generically, arc length is a piece of the circumference of a circle, or you think about it as measuring the crust of a circle, a certain portion of the crust, versus area of a sector is a portion of the area of the entire circle, basically finding the area of an actual piece of pizza. This is a very big slice, but still a piece of pizza nonetheless. So how do we go about finding arc length and area of a sector? Well, arc length, again, is a portion of the circumference of a circle, and area of a sector is a portion of the area of a circle. So if I'm thinking about it, we can actually create a ratio between the arc length is just a portion of the total circumference. And we know for a circle that the formula for circumference is 2 pi r. So 2 pi r is the circumference for a circle. So the arc length is a portion of the total 2 pi r, which we know from our previous math classes is the circumference of a circle. And for the area of a sector, whatever that area is going to be, it is a portion of the area of a circle, and we know the formula for area of a circle is pi r squared. Now, how do I go about actually figuring out what this arc length and area of a sector are? Well, we relate it to what we were studying last unit, which is, in fact, the number of degrees inside of a circle. We know that in any circle, there are 360 degrees. Well, the arc length of a circle, the distance on the edge of a circle, corresponds to a certain number of degrees that inside of the circle, and the area of a sector also, if I were to measure the angle that the sector takes up, that is related to the area of the sector. So what we're putting in here essentially is we're putting some degree measurement that corresponds with the arc length or some degree measurement that corresponds to the area of the sector. So from these two proportions, we're able to go ahead and figure out what the arc length is, figure out what the area of a sector is, or as we'll see here in a minute, sometimes we actually figure out what the degree is or what the radius is, depending on the given information. So these two proportions are what we'll be using predominantly on these problems. So let's jump back over. Question number 1, find the length of ABC. So I want to find the length of ABC, which is I want to figure out what this distance is on the outside of the circle, the actual real distance. Now, this 300 degrees inside on my central angle, we know that this arc is also 300 degrees, but I want the actual length, and I want the length in inches here, because my radius is given in inches, not 300 degrees, the degree measurement. So, since I'm finding arc length, we're going to set up a proportion, and that proportion is made up of a ratio of degrees, the degree measured that we are of the central angle of the circle over the total 360, set equal to the arc length distance over the total circumference. So, ratio of degree to ratio of circumference. Well, if we're substituting in our known information, I see that I'm given the degree measure of 300 degrees, and we see that we're actually given the radius of the circle to be 12. So come in here, I'm going to go ahead and erase this right there. And that we're going to plug in as a 12. And since we're trying to find the arc length here, that means we're going to go ahead and I'll substitute a unknown variable here of x. That's what we're going to go ahead and figure out. Well, this is a proportion. We know how to solve proportions. We just simply cross multiply, giving us 300 times 2 pi times 12 is equal to 360 divided by times x. We'll divide both sides by 360. Now, what we're going to do here is we can focus on this math a little bit. I'm going to multiply everything except the pi in the numerator, which gives me 7,200 pi over my value of 360 is equal to x. Well, okay, so I multiplied all the numbers and left the pi there. I'm going to divide 7,200 by 360, and we actually get an answer of 20 pi. 20 pi is equal to x. So this is called leaving the answer in terms of pi. We could also just go ahead and plug this into the calculator to get the decimal value. That gives, or x is equal to 62.8 inches. In higher level math classes, a lot of times we leave our answers in terms of pi. We don't want to go ahead and worry about that messy decimal, but we could also just turn it into decimal, and we get our answer from that. So we're going to go ahead and use this same proportion idea to help us solve the next two. As you know, here we're actually finding the central angle and finding the radius length, but I'm still going to go ahead and start off with this same proportion. Degrees over 360, a ratio of degrees to a ratio of circumferences. We'll jump over here and we'll get that started on B. So degrees over 360 equals arc length over 2 pi r, so ratio of degrees to ratio of circumferences. Notice here we're actually trying to figure out what the degree measure is, and we are given our radius and we're given the arc length. So I'm trying to figure out the degree measure. We're given that the radius is equal to 8, as we can see there, 8 meters, and we're actually given the arc length measurement of 6 pi. So looking at this proportion then, we can go ahead and simplify. I'm going to start off by dividing the pi's to make my life a little bit easier. And from here, we'll just go ahead and cross multiply. And then going ahead and solve, which gives us that x is equal to 2,160 degrees over 16, which is 135 degrees. So from my given information, we know the 135 degree angle measure would give us an arc length of 6 pi meters from our 8 meter radius. Okay, C, find the radius length. Again, we're going to go ahead and set up with the same proportion and fill in the relevant information. To ratio of degrees to ratio of circumferences. We're given the angle measure of 225 degrees for our central angle. We are actually given our arc length to be 15 pi feet, and we are given the radius value of x. So here we're actually trying to figure out what our x value is for the radius, so that's why I put it in as x. From here we're going to go ahead and simplify. I'll divide the pi's out, and then we'll go ahead and cross multiply. And we'll go ahead and solve from here, which gives us that x is equal to 12 feet. 5,400 over 450, reducing down to 12 feet. Once again, taking a look at these three problems from a larger standpoint, once again, we are starting off each of these problems setting up a ratio of degree ratio to a circumference ratio, degree ratio to circumference, degree to circumference, because we are trying to find arc length. We're using the circumference formula. All of them started off using this proportion to help us solve. We substituted in the known information, and we were able to go ahead and find either the arc length, central angle, or radius value. I'm going to do problem number D here as well. This is a question that's going to be like on the assessment. Word problem, but nothing too crazy. The minute hand on the clock is 10 centimeters long and travels through an arc of 108 degrees every 18 minutes. What is the length of the arc the minute hand travels during the 18 minutes? So once again, notice here we're finding the length of an arc, which means we're looking for an arc length, and we're given some relevant information. So I'm going to set up the proportion to start with. Ratio of degrees to ratio of circumferences. We're trying to find the arc length, so this is my unknown value here is x. We have to be given all the other information then. We are given that the degree measure is 108 degrees. And we're actually given the radius here as well. The minute hand is 10 centimeters long, so that means my radius is going to be 10. From here then, we're going to go ahead and just cross multiply and solve from there. As we can see, cross multiplying, dividing by 360, doing all the math, leave it in terms of pi. 2,160 pi divided by 360 actually equals 6 pi. Notice none of my answers are left in terms of pi here, so I'll do the decimal approximation, which is 18.8. So my answer here is going to be C, 18.8 centimeters. This video went a little long, so I'm going to go ahead and do area of a sector on the next one. Thanks.